Hi, and welcome to Miniature Spectrometers 101, the Raman spectrometer tutorial. Today we will be reviewing Raman spectroscopy basics and looking at various application demonstrations. A Raman spectrometer system consists of a Raman laser, generally characterized for high output power and sharp line width, a Raman spectrometer, which is configured for high resolution and high sensitivity simultaneously, and a Raman probe, which delivers the laser light to the sample and returns the scattered light back to the spectrometer. This Raman scattered light contains unique information about a molecule's vibration and other excitational modes and produces a finger-like spectrum, which can be used for quick and simple non-contact sample identification. In today's demonstrations, we will be using a StellarNet Raman HR TEC cooled spectrometer, a Romulaser 785 nanometer laser, and the Raman probe. We will be using the SpectraWiz software, and we will demonstrate how to take some simple sample measurements. First, open the software and enter the Raman laser wavelength in the setup menu. Once you have done that, you notice that the x-axis changes from wavelengths to wave numbers. Now what we will do is we will adjust our detector integration time. Since we are looking at low-level light from the Raman scatter, we will have to increase our detector integration time. Once you have set your integration time, you must take a dark reference spectrum. You do this by clicking on the dark light bulb icon on the top of the screen. You will see your baseline fall to 0. Now let's go ahead and activate the laser by turning the key switch on the back of the Romulaser. Now click on the ID tab to launch the Spectral ID Raman Search tool panel. Okay, for our first measurement, we will measure maltol in a bag. Go ahead and click the red laser activation button on the front of the Romulaser. After acquisition time, you will see the Raman spectra of maltol appear on the screen. Go ahead and click Capture and then Analyze. Once we click Analyze, we see that there are no matches in the library. So what we'll do next is we will save the file into the library. We'll save this one as maltol in a bag. Okay, good. Now when we click the Analyze button, we find a 100% match to maltol in a bag. For the next application, we are going to measure maltol in a vial, and we will compare it to the maltol in the bag spectrum that we just took. Okay, so go ahead and place the vial inside of the Raman probe vial holder and press the red laser button and wait for spectral acquisition. We get a very similar spectrum as before, and now when we click Analyze, we see a maltol in a bag coming up as a match. We'll go ahead and save this maltol in a vial spectrum and compare the two. Now when we click Analyze, we see that we have a 100% match for vial and a 0.99% match for maltol in a bag. Now let's measure the maltol powder. Hold the probe directly up to the powder surface and hold the red laser button and wait for sample acquisition. Now we see we have two close matches but not a 100% match. So we can go ahead and save the maltol in powder into the library. Now when we click the Analyze button, you'll see 100% match for the powder and very near matches for the vial and the bag. When you click on the text for maltol in a vial or maltol in a bag, it displays the spectrum of the other sample clearly on the screen. You can see that the library search function easily allows you to go from powder to vial to bag, and you get direct hits for the sample containing maltol in every case. Now we'll do another demonstration where we will adjust exposure times in saved library spectra and show direct matches. We will be using acesulfame, which is an artificial sweetener. First we will do it, collect the spectrum with a 5-second detector integration time. Okay. Now let's adjust our detector integration time from 5 seconds to 10 seconds. As you adjust detector integration time, remember you must take a dark spectral reference in each case. Click on the dark light bulb to do so. Now hold down the red laser button, fire, and collect the spectrum, now at 10-second acquisition time. If you click Analyze, you see you have a 97% match for acesulfame and vial at 5 seconds. Let's add the 10-second spectral acquisition to library. When we click Analyze, we will see both of them pop up on our match. Now to compare the two, we simply click on the 5-second spectrum. You can clearly see that the integration time set with 5 and with 10 give you similar results. Now let's do an example with erythritol, a sugar food additive. Click Analyze, and we can clearly get erythritol spectrum. Now let's look at sucralose, an artificial sweetener. Click Analyze, and we clearly get sucralose in a vial from the library. We can compare the library spectrum with the taken spectrum easily and simply. Now let's look at creatine. (94% match for creatine in a vial). Here we are looking at glutamine, a dietary supplement. Here we look at acetaminophen in tablet form. Now we will look at caffeine. Now let's look at some liquid samples. The first liquid we will look at is isopropyl alcohol, also known as rubbing alcohol. Clicking Analyze, we clearly get a match. Now we'll look at acetone. Here we will look at acetic acid, one of the main components in vinegar. Lastly, we will look at some alcohols. We'll start with Everclear. And lastly, we will look at vodka. Thank you for watching Miniature Spectrometers 101, the Raman spectrometer tutorial, and watching various application demonstrations of StellarNet Raman spectrometer systems.